Hi, my name is rayyanrehman, and I'm with FRC Team 8590, or I guess I don't know, I'm graduating, whatever. But so I used to run the CNC machine basically the whole entire season for the team, and I got really good at it. And so to pass down my knowledge, like I'm an old grandpa, I'm making this series of videos to basically take somebody from not knowing what the heck a big CNC machine is to making parts as fast as possible. So today I'll be running you through an example of my workflow and how I get it done as fast as possible, but also like produce good parts. So some basics. This is Autodesk Inventor I have put up right here on your screen. And today I'm going to be trying to CNC one of these, not try, I'll actually do it, but I'll CNC one of these little brackets on the top right, this little 90-degree right-hand corner thing. So this is just directly off of Rev. Hopefully this part will be like useful in the future, that's why I'm doing it. And so I scroll down, and then you can find the files. That's very important. So I wanted this one, the 1-inch 90-degree bracket. So what I'm going to do is download the step file. So this brings us to our first topic of files and different file types. There's a million, quadrillion different types of files, OBJ, STL, vector, whatever else, right? The most important one that you'll use CNCing is a step file right here, STEP. That is the file type that you're going to use. Everything else like STL, it's really not great and it's a hassle and it's just miserable to use. So if you're in Onshape and you're downloading a part like I did often from the Onshape, the robot CAD to CNC, you want to download it as a step. So it'll give you, I'll actually pull up Onshape real quick. It'll give you an option to download it as a whole variety of like file types, but step is the most important. So let's pull the robot up. So we'll go to 8590, escape robot. Okay, so while this loads, step is the most important because then what you want is it'll import step into Autodesk. I'm not going to go into why step's good. That's boring. I think it's boring too. But if this loads, so this is our 2025 robot. May or may not recognize this thing. So there's this little polycard piece, right? So let's say I want to CNC this, which I actually did one day. So you right click and then you go to export. Now in export you can see here there's the part name, format, all these different types of file names I was just telling you about, STL, whatever else. Step is what you want right here, step, and then you hit export. Don't worry about any of this other stuff. I don't know what it does either. It worked out fine. But so you get your step file, right? And then pull it back to Autodesk, and then I'm going to go to top left, and then I'm going to open my file. Nice. I don't know what half this stuff does. You don't need to either. So beautiful. Now you import her apart. There's a cube in the top right hand corner you can use to navigate. I don't have my mouse with me right now, so I'm just using the cube. You can like right click, I believe it is, to like go around it. Now, so we go over to the cam, and this is obviously where we like do most of our stuff, right? First of all, the basis of any CNC toolpath creation, toolpath being like the physical path of the tool, which you obviously are trying to generate here, is a setup. It's really important. So click on setup. So first, let's go through this chronologically. So your machine. So here at 8590, we have an Axiom Pro V5. There's also a plaque on the machine which has the name and specifics and things. You can look for Axiom in this list. You won't find it, promise you. I've looked. So what you do is you select generic 3-axis, and then later on we'll go through a step where you take this generic G-code, which is what Inventor spits out, and then you translate it over to what Axiom or Axiom machine reads. Next up, operation type, milling, don't touch that. Model orientation. This is very important. You really have to, I guess, listen up here. So every time you want to do select X and Y. So right now, coincidentally, my X and Y, which you can see here in the middle of my screen, it's perfect, right? X is pointing to the right, Y is pointing up, and then Z is pointing coming at the screen. Later on, in another video, I'll show you on the actual machine where X and Y and Z is. But basically, you always want X pointing to the right, Y pointing up, and then Z pointing out at you, which you can't see if you're doing like a front-on view. So if it was not perfect like this, and let's say X was to the left and Y was, or Z was up or something, which often the case is, I don't know, it's perfect. I guess I'll buy a lottery ticket today. So what you do is you go here, you go to select X and Y axes, and then you click on X axis. So, and then what you'll do, now if you hover, it turns green. Now what you want is a line that is parallel to that axis. So if you see it, right, X is going to the right. So I want a line that is parallel to, I guess, that horizontal axis. So this line works right here. So I'm going to click it, left click, boom, and now you can see it's been selected because it's turned blue, and there's a little X across from my X-axis thing on the left, little button thing. If you want to delete that line and pick another one, just hit clear selections, which is this little red X. Now I'm going to do Y. So I want my Y-axis pointing up as if I'm looking down on my part. So I want it pointing up. So I want to find a line that is parallel, that is pointing upwards. This line seems to be fine. Boom. I've selected it. And then that would straighten out your axes. So that would make X and Y the right correct orientation if it was jumbled up before. That's really important. Stock box point, another very, very important thing. So here you want to select stock box point, and then you press this little X right here to delete whatever selected thing there is. And then this is all up to you, but how I would basically recommend you to do this is, so stock box point is basically setting your origin. So you know how in math class you have 0, 0, right? And then let's say you go 5 units to the right, that's 5, 0. And so you're locating that 5, 0 point. You know where that point is because it's 5 units to the right of 0, 0. So basically that origin is serving as a point where everything's relative to that, right? CNCing is the same. You need a certain point, which is this stock point which you're going to select, and everything will be relative to that point in the G code. So later on, this will also be relevant as to where you hone and you physically put your origin in the machine, but we'll get into that later. Don't worry about that. So how I always do it is the top left. So if you would click this right now, you would think, oh, top left, there's your top left. However, that's actually wrong. What you want to do is you want to get a more 3D view. And if you zoom in, there's actually 3 points here. I always go with the top of the top left. It's good to keep it always one single point so you don't ever jumble it up unless, I don't know, you don't jumble it up basically. So there's our origin set. So this will be our 0, 0, 0 actually. It's 3 digits because it's X, Y, and Z. Now, the model is already selected, you can see, because there's a red X, which tells me I can clear the selection. But I'm just going to show you I cleared it. And when I hover over the part, it like lights up in green. So I'm going to select it. And now it's been selected. Don't mess with fixture. That's for real machinists and stuff. And that's not us. So stock mode. Basically, there's 2 ways you can go about this. There's the fast, lazy, and efficient way, or the more cumbersome way. For the longest time, I've been doing it relative size box. So basically what this means is, let's say the model you're trying to make is 2 inches by 2 inches by 2, or like 2 inches by 2 inches. Okay, sure, whatever. Make it a cube. 2 by 2 by 2, right? So let's say you have a stock that's 5 by 5 by 5, right? So infinitely bigger than your little cube model. You can either tell it that your stock is bigger than your model, and then you can put where you want your model in the stock, or you can just say that your stock is as big as your model, and then you can go from there. It's not exactly a great explanation. I'll explain it later on another video, but basically the fastest way to go about this is relative size box, and just keep going. Press OK. Okay, editing right on here. When you go into your setup, I actually made a quick mistake. Go to stock. What you want, sorry, I had stock selected. You actually want 0 offset on everything. So 0, 0. That makes it, offset would be like, if you did side offset, it would make it like that much larger on the side. You don't want any of that. You want it exactly the same size as your model. Then you press OK. Nice. Now back to the video.